Hey there, class. Mr. Pusky here. Hope you're having a good day so far. We're continuing with Chapter 10 in Geometry. We're talking about circles in this chapter. And this section is 10.2, which is arc measures. Okay, our essential question is how do we use angle measures to find arc measures? So essentially, arc measures are basically like how many degrees of a circle, like how much of like the line of a circle, like how many matches with how many degrees basically that makes up, right? So basically, like if you have a circle here, right? Oops, can't right here. That's not what I want. If I do a circle, right, and I talk about like an angle like this arc measure would be equal to whatever this angle is in the middle here, okay? So yeah, so let's go ahead and get into this. Yeah, sounds good. So, a central angle is an angle whose vertex, what? Vertex is the center of the circle. Do the different color here, actually. So for example, if I draw a circle here, like that, and I draw a dot in the middle here, and I go like this, and I make a kind of an angle. This is A, this is B, and this is theta. This little symbol here looks like this. It's theta, okay? We have point C here, right? So basically, the central angle would be theta for this one, okay? Theta would be the central angle, which means it's like the angle's in the center of the circle, okay? A minor arc is the part of a circle measuring less than what? Less than 180 degrees, okay? So a minor arc in this drawing here would be, so you can see less than 180 degrees would be like AB. The way we kind of use, like, remember like a line segment was like AB with a little line over it. And minor arc AB is going to be AB with a little kind of like arc like this. That's going to be minor arc AB. All right, a major arc is going to be a part of a circle measuring between 180 and 360 degrees. Okay, and in this case, it's going to be, so AB is the minor arc, right? What's the major arc going to be? The major arc is going to be like, for example, ACB going the opposite direction, right? ACB would be a major arc. So going this direction would be more than 180 degrees, okay? All right, like we talked about, a semicircle. We didn't talk about semicircle. So semicircle is going to be an arc with endpoints that are the endpoints of a diameter of a what? Diameter. How many degrees do you think a semicircle is going to be? It's going to be 180 degrees, okay? So that'd be, for example, a semicircle would be like this section right here, right? This would be a semicircle, okay? All right, the measure of a minor arc is the measure of its central angle. It's what? Central angle. Always named with two letters like we talked about. We have AB, right? The measure of a major arc is the difference between 360 and the measure of the related minor arc. So basically, like, if you do 360 minus the smaller arc, you'll get the bigger arc, right? And so for this case, it's three letters, like A, B, C would be a major arc, okay? All right. Congruent circles are circles that have the same radius. The same what? The same radius. And congruent arcs are arcs that have the same measure. The same what? And they're on the same circle or of congruent circles, okay? So congruent arcs need to be the same circle or on congruent circles. All right, let's talk about measuring arcs now. So measure of an entire circle is how many degrees? 360. And the measure of a major arc is the difference between 360 and the minor arc. And difference is subtraction, right? You do 360 minus minor arc, right? Okay. So yeah, that's how you find the major arc. And a semicircle is how many degrees? It's 180 degrees. Okay. All right, for example 1, it says it wants us to find the measures of arcs of circle C where DF is a diameter. So if you'd like to pause the video and see how you do, see if you can figure these out. Go ahead. All right, so for A, we're looking for this arc right here, DE. Well, the measure of any arc like this is going to be the measure of its central angle, which is going to be 117. So measure of, the way you write this is measure of DE. It's going to equal 117 degrees. And that's it. All right, and then DFE. And when you're doing this, you want to kind of go like the exact letters that it says. Let's use a different color here. So I go D, F, E, go all the way around, right? The exact order. We went D, then F, then E. So for this, what we're going to do is we're going to do, to find the major arc, we do 360 minus the smaller arc that we don't want, which is 117. And so our answer is going to be measure of arc DFE. It's going to equal 360 minus 117 is 243 degrees. All right. And then DEF. DEF is this way. DEF looks like it's a semicircle. And how many degrees is that going to be? Measure of arc DEF is going to be equal to 180 degrees. It's a semicircle. Okay? All right, and there we go. I want you guys, now that we know how to do this, why don't you guys go ahead and do checkpoint 1, see how you do. All right, we're looking for a measure of arc RTS. So we have RTS is this arc right here. Okay, so we're looking for, so measure of arc RTS is going to equal, is that a major arc or a minor arc? It's a major arc, so we're going to do 360 minus the minor arc, which is what? It's 45, which is going to equal 315 degrees. And that's going to be the measure of that arc. Nice. Okay, kind of a new idea, but not really. We're talking about the arc addition postulate, which basically says a bigger arc is composed of two smaller arcs. Remember like the segment addition postulate where we had like, so we have this right here, we have A, B, and this thing is C, right? The segment addition postulate, A plus B equals C. It's basically the same thing, we're just talking about arcs now, right? So we're looking for measure of angle ABC. ABC is this right here, right? What two arcs make up ABC? Well, we have measure of arc AB plus arc what? BC. Ta-da! That's basically the parts added to the whole. All right, so why don't you guys go ahead and do example 2. It's very similar to what we've been doing, but it's going to be including, you're going to have to add a couple different arcs, okay? Give it a try. Okay, so we're looking for arc BD. Now, the problem here is that we could go this way or we could go the other way. We can go to the left or to the right. What do you guys think? Which way are we going to go? Well, BD is a minor arc, which is going to be, you can see that like to the right, BCD is a little bit bigger. So we're going to do this way, right? Because there's not 3 letters. We're not going to do the bigger part of the circle. So what makes up BD? We have measure of arc BA plus measure of arc what? AD. So that's going to be what? 55 plus 105, which equals what? 160 degrees. Awesome. Then we have measure of arc BCD. BCD is this one right here, right? Which arcs make up that? Well, we have measure of arc BC plus measure of arc what? CD. That's going to be 140 plus 60. That's going to be equal to 200 degrees. And that's it. Alrighty. Okay, so identifying congruent arcs. So with this, what we need to know, for these to be congruent, they need, they need congruent angles. And then they need same or congruent circles. Okay, for them to be congruent, they need the congruent angles and then the same or congruent circles. Okay? And then, like for example, congruent circles, just for fun here, congruent circles, they have the same radius. Okay, so those are the things that we need to be able to prove this here, okay? Now, knowing that information, why don't you guys go ahead and try A, B, and C. See if you can figure it out if you think that they're going to be congruent arcs or not. Give it a try. All right, we're looking at B, C, and D, E. So we have these angles are the same, so that's good. Congruent angles. Are the circles, are they on the same or different circles? They're on the same circle, and these are the same radius. So we can say, yes, these are congruent arcs, okay? Because we have congruent angles, and they're on the same circle. And that's what makes them congruent arcs, right? If they were the same angle, but they're on, like, for example, if we had a big circle and a little circle like this, and we went like that, right? This arc is obviously smaller than this arc, right? So that's what we mean by same angle but different circles, size circles, okay? Now that we did one, why don't you guys try B and C if you haven't already? All right, for B, looks like we have, let's see here. We have the same angle. These are both 80 degrees here, but are they congruent circles? No, we have congruent angles, but not congruent circles. You see how the circles are two different sizes, right? This is the radius for the big one, and this is the radius for the small one, which is a little bit, the blue one's definitely bigger, so, okay? How about C? What do we think here? Well, the angles are the same. They're both 90 degrees, and also we know this radius is, these are congruent, so that means that they are congruent circles. These are gonna be yes. They are congruent angles. And, what does that say? That's weird. Angle circles. And congruent circles. Okay, so that's how we prove these angles are going to be, these arcs are going to be the same. All right, we have some checkpoints here. Why don't you guys go ahead and try these, see how you do. All right, from example 2, we're talking about, looks like we're talking about BCA. So BCA, and we're looking for ABC. So let's go through these together here. So measure, come on you. Let's see here. So measure of arc BCA is going to equal, we have 140, I don't have the diagram here, plus 60. There's 3 arcs to make this up, plus 105, which is going to equal 305. And then measure of, let's see here, ABC is going to equal, we have 55 plus 140, which is going to equal 195. So these should be the angles, or the measures of those arcs, okay? All right, last one. And the diagram at the right is PQ congruent to SR, why or why not? It's going to be yes. Now, why is that? Well, they are congruent angles, and they're on the same circle. All right, and that is good. That's all I have for you today. Thank you for watching. Have a great day, and we'll talk soon.